Okay, good afternoon and welcome to the 9th session of the Spring 2017 Sunoikis Digital Classics program. As you'll be able to see, yet again, I'm not Monica. She's away this week, so I'm filling in the introduction for her. This week we're joined by two people who are both new to Sunoikis Digital Classics this year. Francesco Mambrini from the Deutsches Archäologisches Institut and Matteo Romanello from the Deutsches Archäologisches Institut and from the Lausanne University jointly. And they will be talking about named entity extraction. This is the first of two sessions on named entity extraction. The second will be in, I think, 3 weeks' time. And you should all have a bunch of links and passwords and so forth that Matteo and Francesco have shared with you beforehand. We've specifically been requested that if anybody has any questions during this process, because it can get quite technical, do feel free to interrupt if you're in the common session, and if you're watching on YouTube, you can use the live chat there to ask questions, and we'll try to keep an eye out for those questions and respond to them as we go along. So I'll hand over now to Matteo, who I think is going to start.
Thank you, Gabi. I should have unmuted the mic.
Yes, you're good.
Okay, great. And I will now share the screen. Here we go. You should now see the slides.
Yep, all good.
Okay, great. Well, it's a great pleasure, first of all, to be part of Sunoikis Digital Classics. My name is Matteo Romanello. I'm from the DI, as Gabi already said. So the plan for today, what we're going to try to do, it's a bit of a mission impossible. Because it's quite a lot of content. So we'll try to do essentially three things. Introduce the task of named entity extraction, which fits into the field of natural language processing. Introduce basic concepts of programming in Python. We don't want to teach you how to program and do NLP in 1 hour, but to give you enough concepts of programming in Python to be able to follow along with the examples that we are going to show. And then indeed show some hands-on examples of how to do named entity extraction in Python. The environment we are going to use to run the Python code is called Jupyter Notebook. It's essentially an interactive computer environment which consists of 3 elements: a notebook server, and a kernel. So the notebook is the one you see in this slide, and it's a combination of code snippets and text providing explanation about what the code does, but also objects that are the results of running those code snippets. And then you can also have other multimedia objects embedded in the notebook. This notebook runs within a notebook server, and in this case, the server is to be found at the address nlp.bearings.org at the port 8080. And you should have received a password to be able to log in into the notebook server. And the third component, it's a kernel. A kernel is essentially, it's a Python process that runs in the notebook server. And this process takes care of running the code snippets that are found in the notebook. So I will go now to the notebook server and also log out so that you can see how it works. So first of all, we copy the password that you have received by email. When you log in, this is what you see. In the instructions in the GitHub Wiki, we ask you to make a copy, and if you want to run along the code, run it from a copy of these notebooks. So I will show very briefly how you can make a copy. Essentially, you select the 2 notebooks, click on duplicate, they will be duplicated. And now you need to rename the notebook. You click on it, and then by clicking on the title, instead of copy, we are going to append the initials. And then you can close and stop the notebook. First, and then we also do it for the second copy. We do this because if several people run the same code, they will get very fuzzy and random results. So that should be avoided. Okay, so we have now done a copy. When we go into a notebook, there are several commands, several menus. It is possible to save with this icon, to export a notebook, to download it in several formats, to have a print preview, which is essentially a static HTML view of the notebook. Another key thing is the kernel. So the kernel, it's indicated by this circle here on the top right of the screen. And this kernel is the Python process that executes the code. So this kernel can be stopped and reset. And when it's active, then the code, the icon will change. And to restart the code, you have this menu. You can interrupt and restart the kernel. And you will see here the code on the top right will change, say kernel ready, and then it's been restarted. So much for the, well, no, and there are also, another important thing is there are two types of cells. So each notebook is made of cells. Cells can have markdown, like in this case. So if I enter on a cell, then I'm able to edit the content. And if I press Shift Enter, then will be executed. So if I execute a markdown cell, then it just renders the markdown. But if I execute a Python cell, then like in this case, you don't see any output, but I have executed all this cell with several imports in Python. So this has been executed. If I enter, I can edit it. If I do Shift Enter, it gets executed. Okay. I think it's enough for the Jupyter notebook environment. The reason why, very briefly, the reason why we chose it, it's because saves us the time of showing how to install Python on your local machine. And the very cool thing is also, it's an interactive environment. So you can see immediately a code snippet and also the output, the result it produces, essentially live. And that's a big advantage for, especially for teaching a bit of Python. So a bit of definitions about briefly on named entities. So a named entity, it's an element of a text that designates a referent. And a referent is a person, or more generally a thing, to which a linguistic expression refers to. And we can have various typologies of reference, so various things that can act as a referent. Most commonly, you have persons, organizations, and locations. As named entities, you can also have temporal expressions, amounts, or currencies, or percentages that are mentioned in the text. But then if you move to another domain, like biomedicine, then we have different entities, like, for example, genes and proteins or DNA. And if we go to classics, entities become ancient places, ancient people, and bibliographic references, for example. So the referent is domain specific, and it changes depending on the domain in which we are. Just to give a short example of how the input and output of a named entity tagger works, what you see here in this slide, it's a demo from Stanford University of their named entity tagger, the so-called Stanford named entity tagger. Here I've input as text input a part of the Wikipedia page about Homer. I submitted it. In the background, it's been processed. The named entities have been extracted. And what you see in the output is the same text, same input text, but with the highlights of the different entities. Each color represents a different entity type. We have organizations, locations, persons, or a mixed entity. Another example, just to go a bit more in details of the different tasks of named entity recognition. In this case, another example of a Wikipedia page about Aaron Swartz. So in this case, we have two entities, Aaron Swartz and Brooklyn, New York, so a location, that are related together by a sentence. Aaron Swartz was found dead in Brooklyn, New York. So a typical named entity approach to extract the entities from this text will be in several steps. So the first step is to recognize the words Schwartz and Brooklyn, New York, as being named entities, very generally. So it's the recognition step. Then we classify them. So Schwartz as type person, and we classify Brooklyn, New York as a location. Then we can also extract relations between entities. So the bit of text was found that in represents a relation between a person and a place. And the last step is trying to disambiguate these entities, so to assign to each entity a unique identifier. And a quite common approach is to use Wikipedia pages as identifiers for these entities. So we need to distinguish, the system is to distinguish between several people named Harlan Schwartz, and we are referring to the activists. And for New York, we need to assign a unique identifier for the place we are talking about. I will now hand over, I will mute myself and hand over to Francesco that will cover the basics of Python.
All right. Thank you. Sorry. Thank you very much, Matteo. I should have unmuted my microphone. Am I unmuted? Yes. Yep. Okay, good. And do you see my screen now with the plan of the lecture and everything?
Yes.
Wonderful. So, as Matteo said, this lecture has basically two aims. One is to show you how some operations on text, like some information extraction on text, is performed. So give you an idea about the tests of named entity recognition and how to extract this type of information and classify this information from text. And the other one is to show you how we could do something like that with by writing your own programs, your own scripts in Python. Now, realistically, we don't want to teach you. We don't think we are going to teach you how to write a fantastic program in Python in like half an hour. So the aim of this the following part that I am going to do is just to show you the very basic concepts of Python's syntax and the basic operations that are done in Python, to be able to follow along when Matteo will use some of these of Python's elements to interact with text and perform some named entity recognition. But believe me, it is amazing how much you can do even with just the very basic aspects that I am going to show you in this in the next minutes. I am not a professional programmer, so maybe what I would say is just a very trivial version of what professionals will be able to tell you. But you will find plenty of links both here and in the wiki page to just get a deeper knowledge of the things that we are just touching upon in this lecture. And if you already know something about Python, then you feel free to go out and have a cup of coffee, because what I'm going to say will not be very interesting for you. So as I would say, it's amazing how many things you can accomplish with some well-written lines of Python. Or you can go from a very easy script that will just manipulate your files to writing user interfaces that perform very complicated tasks and write professional software. But obviously, we will start by something very simple. Like in this case, you should be able to follow along in the watching at my screen. And as Matteo told you, even compiling your own, running your own code in. But if you want to do so, use our own notebook, but please copy your notebook as Matteo showed. So basically, we will just start by doing something as easy as summing tasks 2 plus 3 and get the results of 5. Well, obviously, this is a very legitimate, very respectable first line of Python that we've just written. But obviously, you might be interested to do something a little more complicated than that. Normally, when you write some code, you just expect to get some input, process this input, and then produce your final output that is what you wanted to obtain. But as soon as you want to do that, then you need something to move your data along, right? To store your input, to store the results of the processing of your input, and then to just return your output. Well, variables is what you use to store your contents. What is a variable? Variable is just a variable is just a placeholder, a name that is used to store some data and to be referenced in your program. A typical metaphor that is used in tutorial is a shoebox, right? It's a box where you put a label on and you put some content in, and then you move your content along. In Python, it is as easy to declare a variable and fill it with some content as that. You see in this line of code, results equal 2 plus 3. Then let's print on the screen the content of this variable. Here we go, 5. By the way, you saw a line in here in this cell that is now has, after we run it, the number 3. A line written with a pound sign. This is a comment. Comments are not executed. Are there just to be it's typical from programming and markup language to have lines of content where the writers just put some instructions, some notes, some whatever, and they're simply ignored. They're not executed. You see that in this in line number 3 of this cell where actually I am, there is a print statement. This print statement is not executed, whereas in line 5 it is. So now, guess what happens when you use the result variable and, for example, sum the number 5 to it? Can you guess it? Yes, of course. You get 5. That was the content of the variable that as we defined it before. Plus 5, 10. Python, it's very easy because you don't need basically anything. You just use, you don't need to define, as you do in other languages, your variable, to declare it before you use it. You simply use it. And also in Python, you don't have to worry about what kind of data goes into the variable. You use it and you fill it with some kind of data. But it is important, and we'll see why, to know what goes into a variable. So what kind of values can we put into a variable? It's more complicated than that, but we can start by saying that it's basically 4 types of values. Integers, we saw them, -1, 0, 1, 2, 3, 4, etc. Strings, which are very important if you're dealing with text. So it's typically a letter, a sequence of letters, words, so sequence of letters plus punctuation marks plus spaces, or even Unicode characters. This, if you know something about Python, is typical of Python 3. Python version 3 is a little bit different in Python 2, but let's not worry about that. There is in the appendix something about the difference between Python 2 and Python 3. Floats. So floats are basically numbers with decimal points. So for example, the pi number, 3.14, etc., or the Euler number, 2.7, etc. Or booleans, which are just 2 values, true or false. As I said, you can just go ahead and define your own variable and use it. But if you're not sure what type of value you're dealing with, you can use a function to tell that. So let's run. The function is type with some content or some variable, right? So in this case, it returns a string because I am the alpha and the omega is a string. In this case, we return float, of course, and this is a boolean. As I said, different from other languages, you can switch. So result was holding 5, so we expect to see integer, of course. But let's say that we redefine results and we put some string in there. Results, yeah. Oh yeah, of course, I call it results. Yeah, that's a string. Oh yeah, but that was not the point of our experiment. It was using the same result as before, right? That's 5, and now we say that we want to turn it into a string. We want to store a string instead here. It's a string now. Don't try to do that, for example, in Perl, because you can't. Okay, now something about strings. How you declare strings? You do it by by defining a variable with the content of a variable with between single or double quotes. Totally indifferent which one. Now let's see something interesting. What happens if you forget the quotes, and what happens if you put quotes around the number? So let's say we want to print hello like that. Oops, Python is complaining about something. It's about complaining that name hello is not defined. Why is that? Because if you don't put quotes around, then Python expects this to be the name of a variable, indeed. So let's rerun this cell by saying hello equal goodbye. Now it doesn't complain anymore because it prints the content of the variable goodbye. If we want to print the message hello, we put it into quotes. Now we are printing the string hello. Quotes around this number, around numbers. Well, for Python doesn't care. It's just a string as the double quote hello, close double quotes. Why is that so important then? If we said Python doesn't care exactly what type of value you put into a variable as long as you know what is there. Well, it's because string, integers, floats, booleans have different behavior, so they do something different when they are processed. Let's try to sum the string 2 and the string 3. What do we get? We got 23. So the two strings are chained together. They're not summed. So if you wanted to sum the string, the integer, the number 2 and 3, then you have to convert these strings into number. You can do that by using the int function in Python. So yeah, here we go. You got 5. If we are working with strings, plus sign is used to concatenate the strings, and it's something that sometimes you want to do. Like for example, if you want to append not very the word interesting. Here we go. It's another interesting thing is that variables can also hold not only data like that, but other types of data, the collections of data. We'll see, there are a few of them in Python. We'll see, we'll have a very brief look at lists and dictionaries, and especially lists. So lists are just like this one in this cell. A collection of comma-separated data that are declared like that, with between square brackets, right? You see, if we run the type function, it returns at least. It is a list. This is instead, it's a dictionary. So a collection of key column value pairs. This is a dictionary. There are also other type of collection, but we won't worry about that. You see links over there if you're interested. Remember that you can always download this code on your own, rerun it, modify it, go through the link, and etc. You'll find everything in the SunoikisIS GitHub page. Item in lists are accessible using their index, so numeric indexes that start from 0 and goes to the last item -1. We'll see. So that's the first element in this list. We call it like Beatles 0, and we got the first element. Or you can even go backwards, so using negative numbers. If you use Beatles -1, you access the last element in the dictionary, in the list. Sorry. Dictionaries that are key value pairs are accessed using the key as index. If you try with, let's try it, with the numeric index like we did with the list, doesn't work because the key is not recognized. Very quickly, there are a bunch of methods that you can use to manipulate lists. Lists are easy to manipulate. For example, if you want to add an element, you can use append, and the element is added as the last, like in this case, Billy Preston. You can always learn the index of an element by using the index keyword, like this, index method. You can insert element that is predefinite index. If you want to add one element to in the index 0, you would write something like that, right? And so now George Harrison becomes index number 3, and you see the list over here. Most importantly, that's very interesting, you can slice very easily the list. So say if you want just the elements between 1 and 5, here you do it. Now, do you notice something strange here? Yes, you probably guessed it right. You don't get, if you write something like that, some code like that, so Beatles 1:5, you don't get number 5. You only stop at number 4. So the last, the number that goes after the colon is not inclusive. You see, because number 5 is Billy Preston, and it's not in this list. What happens if you specify something? Well, an element that it's too high, yeah, you got an error. There is no element Beatles indexed as 7. If you want to know how long a list is, you use a specific function that is called length, that returns you the length. Do remember that you can't use length as easily as that as index, right? If you try, obviously you get an error, because as we said, the index is started at 0, so it will be one number too big. So if you want to do that, you always have to use the length -1. Here we go. So yes, indeed, there are 6 elements, but they are indexed from 0 to 5. Now let's move to something more interesting. Most likely when you're writing some code, you are interested in doing a bunch of things with your input. One of the easiest things that you may be interested in is to check, like for example, if you want to read some file, check if a line of your file starts with a capital, or if you're looking at a bunch of words in a sentence, if this word is a named entity, right? Something like that. In order to do something like this in your code, you use a statement that is called, it's very typical of programming languages, every programming languages, that's called the if statement. And it's something that specifies that some part of code is executed only if some specific conditions are met. In the easiest form, if statement is just a syntactic structure that checks whether, for example, a variable, the value of a variable is something, like in this case, right? We define the variable holding the name of Paul McCartney, and we check if this variable value is Paul McCartney, then print this line, and indeed, it is executed. So, mind this code. Line number 4 is executed only if the condition that is specified in line number 3 is met. It's very easy to use if statement in Python. Basically, you just specify, write the keyword if, specify the condition that is met here. Do be careful here. This is a comparison statement. If you just use one equal sign, you're assigning a value to a variable. If you use 2 equal, you're checking that the variable has some type of value. In this case, this condition is met. Here we go. Mind, this is important, mind the indentation very much, because this is essential in the part of the statement, because it's just, in Python, this is one of the probably most famous, and either you love it or you hate it, characters of the Python syntax. It's just the indentation, so the space between the beginning of the line and the beginning of the statement that tells that this part of the code is executed as part of this statement. Right. So what happens if the what happens if the condition is not met? Nothing, because here in this cell, the value of bassist is checked against this string. They are not equal, and so nothing is. So this part is simply ignored. But as I was telling you, mind the indentation very much. What happens if we cancel this indentation? Of course. Now this line is not part of the statement anymore, and so it gets executed anyway, right? If we put it there, then it's part of the if statement, and it's not executed. So this is something very tricky, typically tricky. In Jupyter, if you write something after if statement, indentation is taken care of automatically, so it will already start at the right indentation. If you're using any text editor, you might be in trouble sometimes, because you have to be consistent. It's the typical use is either to use a tab, right, or 4 spaces, and as one level of indentation. But be consistent. You can't mix it up. It can even be 2 spaces, but then it must be 2 spaces all the time. Okay, so most of the time, what you want to do in the if statement is just to specify what happens if a condition is met and what to do if the condition is not met. Like in this case, we defined bassist in line 1 as Bill Wyman. We checked against the value of Paul McCartney, doesn't correspond, so the line number 4 is not executed. But we tell this program to what to do if the condition, like in this case, is not met, and so print this line. What happens if we put Paul McCartney here? Very easy. Let's see. I probably misspelled. Yes, indeed, I did. Yeah. Yes, now in this case, condition of line 3 is met, and then this line is printed. If we leave the variable empty, obviously it's not Paul McCartney, and so here we go. Okay. We can specify many different conditions, of course. So with using the elif here in line 5 keywords. So check if condition is line 3 is met. It's not met, then check if it is met at line 5. In this case, it is indeed met at line 5. So line 6 is executed. Let's say, I don't know. In this case, not the condition in line 3 is not met, condition in line 5 is not met, and then we pass to the else statement and we execute that. Another thing that you typically want to do is loop over items of your input. So you segment your input into different parts, and then you check, like for example, you divide a sentence into words, and you check if each of these words is meeting some condition, right? For example, that's what you can do typically with a for loop. So which is simply a statement that iterates over elements. And typically, one easy thing to do in this case is using lists. Lists are iterables, and so with a for loop, you can simply specify what to do with each item in a list. So in this case, for example, this is how you write for statement in Python. Let's break the code down to its part. You get the name of a variable here, right, where we save each item in the iteration. It could be whatever, really. In this case, it's very convenient to just use the first letter of your list. This is, so for name of the variable, in, it's a keyword, the list you're iterating over, all right? And then in this line, in line 2, the statement that you want to execute for each line. Again, do mind the indentation. You see, same thing as in the if statement. The indentation tells you that you're part of the for statement. Let's combine for and if statement, and this is very interesting, right? As an homework, you can have a look at and comment what's happening in this part of the code. I said many times that one typical thing that you want to do is reading the content of a file and do some operation. That's very easy in Python. You can just start this operation by opening a file, create a file handler that opens the file, and but you have to specify what you want to do with this file before when you open it. That is to say that you have to specify whether you want to open your file in read mode, that simply reads the content and doesn't modify the file, in write mode, that it's used to write down some content to file, or in append mode. We see in a second what's the difference between that. So here is how you do that. Open some file in read mode. You will notice in the future that this can be omitted because the read mode is the default. So this is typically what you do. You read the full content in one variable with this code, and then you can do a lot of stuff with that. Typically, the easiest thing to do, since file handler in this case is iterable and each part of the content is a line, you can simply do that, right? For L in the file content, print L. Once you're done with the file, don't forget to close your handle, like that. All together is this code. There is a shortening version that, using the with statement, takes care of everything. As soon as it's finished this part in the indentation, the file is automatically closed, and if there is some error, everything in the mess is cleaned up. Mind the indentation, right? This part is in the first indentation tells that the for loop is part of the with statement. Here we got the double indent, right? That's exactly what you expect, because this part is not only part of the with statement, but it's also part of the for loop. Here we go, exactly the same thing. How about writing? Same thing, but with the W keyword, right? Here we write some content, this content. We have created this file, right? This text.txt file. Here we go. You see it here somewhere. Yes, it's here. Test.txt. Okay, don't worry about this code. This is just to say list the content of a variable. And again, before we can do anything with this text, like opening it with other programs or stuff like that, you have to close it. Now, let's print the content of this text. Good. That's exactly what we have written in that. Now, again, we can use the with statement. Now, let's do that. Let's reopen this with the with statement and with the W. And with the W keyword. And write something else. Oops, new content. Let's see what we have done, right? Let's now read the content of text.txt. Oops, new content, and that's all. We don't have the content of that we've written before. Why is that so? Because you must be extra careful when you open something in W mode, because it will erase all the content that there was before. So let's keep this in mind. If we open a file in W mode, if the file that with the name that we have specified doesn't exist, new file with that name is created. If it does exist, it's completely overwritten and all previous content is lost. You use A mode, the append mode, if what you want to do is just add some content at the end of the file. So here we do that again with the statement. And here is the content. Oops, new content, which was the content we created before. Then we opened the file in append mode, and then the content that we have written here is added at the bottom of the file. Now functions. Well, maybe, well, okay, we got some time to talk about function. You perhaps have noticed that I have copy-pasted infinite times the same code over and over, and what I've done is just writing code that cannot be reused unless I go over, rechange some values and everything. This is typically not what you want to do. Typically, you want to write some piece of code that executed the same operation no matter what variables you are dealing with. So you can just write down, like for example, in the here we have written this with open text path and then print the content so many times, and every time we had to write the same thing over. And if we wanted to change it to open another text, then another text file, then we have to specify to go here and change the file. This is okay when you just got 2 lines like this, but if you got a lot of process that you want to do, this is not okay. So typically what you do is define some function that takes some arguments, so it's a variable, that's another placeholder that specify that something happens whenever you put something there. And then what are the operations that are to be performed whenever you invoke this function. So this is how you would write this very simple function that I said before that lets you avoid to just repeat typing with open file name as f, print, f, read all the time. Next time that we want to do that, we want to just inspect the content of a file name, we can do like that. We can just use the content of this file. We can just use the name of this function, passing the file path of the text file that we want to use. So in this case is that we can just use another file from this, so the README, for example. Here we go. That's much easier. Also because if you want to add new functions, if you want to add new functionality, if you want to modify something in the code, you just do it once, and that's all. That's done forever. Notice that this function prints out something, but doesn't give you anything back. Your typical function, most of the time, not always, but most of the time, performs some operation with the inputs that you pass to this variable, the arguments that you pass to this variable, and returns some new stuff. easiest example in the world you can think of is a function that sums the two arguments that you pass to this function and then returns the result. Even more compact, even shorter version would be this one. So mind the indent once again, it's part of the function, and mind this statement as well, return s. So it says that save the, in this case, it says save the sum into a variable called x, return s. Here we go. Now you can use it. You can typically you save the product of a sum of the function into a variable, and then this variable can be used to do something. Last thing that I want to show you is errors, and how to deal with errors, because we all make a lot of mistakes, and believe me, when you start, you make even more mistakes than if you. But even if you are a pro, you do a lot of mistakes all the time. So, and you shouldn't be scared about those errors, though. There are anyway a couple of things that that could be said for errors, because there are types of errors that can actually become useful when you program, because you can be trained to, you can think of what kind of errors will eventually show up in your code, and write your code so that some of these errors are handled and some code is executed and your program won't stop, like we saw before. So there are two types of errors, as I was saying. So let's see what happens if, in the if statement that we used before, we forget to use the indent. Well, it's pretty clear what's happening, right? Python is telling us a lot of information. So be careful and always read this information. This is the first piece of advice. They're not always very useful, but in this case, they can't be more useful than that. I mean, more clear than that. It's telling us that there is an indentation error and that Python was expected an indented block. And yes, it was expected an indented block. And so yes, we did forget about the indentation. If we put the indentation there, well, nothing happens. This is kind of different because this is badly written Python. This is non-grammatical Python syntax. This is not a non-grammatical Python syntax, right? This is something that is perfectly legitimate. But Python is complaining. Why it is complaining? What is going on? Well, we never defined the variable var here. So we are trying to use it here in an if statement, but we didn't define it. So Python doesn't know what var is. If we do that, say, for example, it's an empty list, then var becomes defined. Well, let's say not an empty list, but let's say blah blah. Yeah. What you get in this case, if var is not defined, so let's see it again by using something that is really not defined, is an exception. It's technically called an exception. Now, exception can be handled, right? You can do something with them. You can tell Python not to ignore them, but to treat them and to sanitize them in a way. Let's see what happens if we try to print the file content using this function that we defined before on a file that doesn't exist in the system. Yeah, we got another error. We got another exception. File not found error. Again, this syntax is perfectly legitimate, but it still gets us into trouble because Python doesn't know what this file is. We can rewrite this function in a way that this is taken care of. So let's have a look at this code. Just encapsulate what we were trying to do with the file within a try statement that is followed in line 6 by an except statement that says what to do in case there is a file not found, which is exactly the name that we got here, a file not found error. Right? What to do? Just print something else. Don't print the content of the file, because obviously there is no file content, and there's no file to open, and there is no file content to show. But print something else. So let's run this with a non-existing file as we tried to do before. Well, file does not exist. Nevertheless, I do like you, and I will print something to you anyway. All right, so this was pretty much a very, very, very brief overview of the Python syntax. I hope it was understandable and it was not too much information. But again, you can go back and check it as many times as you want, and rerun it as many times as you want. And now I get the word back to Matteo. The word goes back to Matteo for something else, even some more fun with Python.
Yes. Okay, let's share the screen again. Good. So in this last part of the common session, we will basically put together most of the notions that Francesco introduced, and try to show how you can actually use them to write some code that extract entities from some text. And we will be working on the Bello Gallico by Caesar, so a text written in Latin. So first of all, we start by resetting. So restarting the kernel and clearing all the output. The very first thing to do is to import the libraries that we will be using. So libraries are external bits of code that can be imported and run and used. And we will be using essentially 3 libraries, and the first 2 more intensively. So the natural language toolkit, the classical language toolkit, and the MyCapital.
Yes.
And MyCapital.
Because Matteo, can...
Yes.
Sorry.
Yes, sorry, I forgot to say something. Sorry. Can you all hear me? I forgot to say something. When I talked about the functions, I forgot to say that many people have defined many functions, and they typically are stored into libraries that are external bits of code that you don't need to redefine anymore, but you can simply import, as Matteo was showing. I'm sorry, Matteo.
No problem. Okay. So to import these libraries, you use the import statement. And also, if you just want to import specific parts of these libraries, you can also combine it with the from statement. Like in this case, for example, we import the whole NLTK, but we also import explicitly the Stanford NER tagger from one specific section of this library. So let's run this bit of code. It imports all the libraries we need, and also all the classes or functions that we will be calling during within this notebook. To be able to import these libraries, you need to have them installed beforehand. So for this session, we stored all these libraries in the on the machine where the Jupyter notebook is running. But if you want to do it on your own local machine, then you need to install all these libraries before you're actually able to import them. You can also print the version of each library, which is contained within a special variable. So in this case, we print the version of LTK, the version of CLTK, and also the version of MyCapital. So this variable contains a string, and the string represents the version under a version control system of the software at a specific point in time. So to play with the entity extraction, obviously we need a piece of text. So now we could have had several ways of doing this. So one way could have been copy and paste the text from the Perseus or the Latin library, copy it into a text document, and then read it from the file into a variable using the methods that Francesco showed. Another method is to use the corpora that are included in the CLTK library. And there is also a third method, which I find very interesting and also very cool to show, which is using a machine interface to the Perseus digital library. So this machine interface is called Canonical Text Services API, and allows us to get bits of text essentially by calling them by name. And these names are CTS URNs, so Canonical Text Service Uniform Resource Names. These CTS URNs are essentially, as Charlotte Luchet once called them, social security number for text. So they identify unambiguously text, versions of text, and also parts within this text. So the syntax, which is displayed here in this image. And by the way, this image is imported using this markdown statement into the notebook. So it's also a way of showing what you can actually embed into a notebook. So if we render the image, this is the syntax of CTS-URN. So you have a first part with prefixes, URN and CTS. Then you define a namespace, in this case, Greek lit, which stands for the Greek literature within Perseus. And then you have the address of the work you're talking about, which is composed of a text group, in this case, TLG 0012 for Homer, a work, TLG 001 for the Iliad, and then also one specific version of the text, in this case, the Greek text in Perseus. And then you can also append a passage if you want a specific passage of that edition. So CTS-URNs provide different identifiers with different levels of granularity. To come to Caesar, which is our example, you have a URN for Caesar, CTS-URN for Caesar, a CTS-URN for the Bello Gallico as a work, but you can also go more deeply into it. You have a CTS-URN for the Latin edition of the Bello Gallico within Perseus, within one specific instance of Perseus. You can refer to book one, to the entire book one within this text. You can also be more precise and refer with the last URN to book one, chapter one, section one of the Bello Gallico. To discover what is the CTS-URN for a given text or a given author, the Perseus catalog is your friend. So by going to the catalog and searching through it, you can find out what these social security numbers for authors and texts are. Now, once we have a CTS-URN, we can ask this API of Perseus to get back a text passage corresponding to that URN. And we will be using the myCapitanes library that provides, it's a very complicated, it's a quite complex library, so I won't go into details, but essentially takes care of taking the URN, going to the API, making a query to the API in the right format using the CTS protocol, and then delivering the result of that query back to your browser, to your environment, essentially. So we define a CTS-URN for, in this case, the Bello Gallico, the Latin edition. We set a resolver, which is an object defined in the myCapitanes library, and we pointed to one specific instance of the CTS service which is serving the Perseus text. So we define the resolver, and the resolver can give us information about the text. So in this case, for example, if you request from the resolver calling the get metadata method, we request the metadata about the text. The metadata that we get contains, for example, the canonical citation structure of this text, which is book, chapter, and section. That's what we printed now to the standard output. And this is very useful if we need to know, if we need how to cite a given text. But now we wanted the first book, not the whole work. So we define a variable containing a CTS-URN to which we append number one, which stands for book one. We ask the resolver to give us back the passage corresponding to the CTS-URN. And this comes back both as text, but also as TI-XML. So we need to export it. We are just interested in the text right now, not in the XML. Calling the method export of a passage, we can get back the text, corresponding text, and we store it into the shoebox called the Bello Gallico book one, which is our variable where there is a text. Now, if we want to see what's inside the variable, and there should be the text of book one of the Bello Gallico, we print it to the output. So in this case, I remove the comment. If you run a bit of code with a comment, doesn't do anything. If you remove the code, if you remove the comment, then it does something. In this case, it's printing the content of the variable. And as you can see, inside, there is the book 1 Latin text of the Bello Gallico. We use the API. You can also, there is also normal user interface, and here there is a link if you want to check it out. We can also import a web page within the notebook, as I'm demonstrating here. And here you see what's at this address. This is the user interface for the same CTS repository. Okay, so now that we have the text, we can, for example, print the number of tokens contained in the text. So what we are doing here is to call the variable, the Bello Gallico 1, which is a string, and then call the string method split that splits the string into segments. And as a parameter to the split method, we give a white space. So what we are saying is split the text contained into the variable, the Bello Gallico book 1, by white spaces. And what we get back, it's a list containing 8,176 tokens. You can also, here I've just printed the length of the string using the length function, but you can also, using the slicing notation that Francesco showed, print the first 100 tokens in the contained in this list. And here you see the first 100 tokens of the text displayed as a list. So we will try out and combine 3 different methods of extracting named entities. The first one is a baseline. So a baseline in NLP jargon, it's a method for extracting named entities, in this case, that can serve as a term of comparison to evaluate the accuracy of other methods. For example, to compare our baseline, very basic, very simple, with CLTK or with NLTK. And the algorithm, so to say, that we implement in this baseline, it's very simple. So we go through the text, token by token, and if a token starts with a capital letter, then we say, okay, this is a named entity. So it's a very dumb algorithm using one single type of entities, but we can use it as a baseline. And just to show how do we know if a string is starting with a capital letter? Well, there is a built-in method of a string, which is called isTitle. So if we call, for example, the isTitle method on the string t, capital T, we get back a Boolean saying t is capital, title case. If we use lowercase t and use the same method, of course, we get back a false. So what we do is to use a for loop to go through the text and check if each token has or has not a capital initial. So we run the code, doesn't do anything. Let's explain what it does first. So first of all, I initialize an empty list, an empty shoebox called tag tokens, where I'm going to store the tokens. Then I take the text of the book 1, my text, that we split, we tokenize by white space, as I showed before. And with a for loop, I iterate through each token. And for each token, there are 2 variables that get automatically initialized by enumerate. N, which is going from 0 to the, it's an incremental number, and token, where there is the token of the text that I'm currently considering at a specific point of the loop. So if I print, for example, the last value of n, I get this number, and similarly, if I print the last token, then I get s dot. Okay, so this is what the code did, iterating through the tokenized text, And then there is an if-else statement. So for each token, we check if it's starting with a capital letter. If so, then we append to the list that we initialize at line 2. We append two bits of information in a tuple, so in a data structure which is called a tuple. And a tuple, it's similar in the behavior to a list and looks essentially like this. So in this case, it's a tuple of size 2. The first element of the tuple is a token, and the second element is the entity type. But in the case the token is not starting with capital letter, then we say, we just append a label, O, which stands for other, saying this token, it's not a named entity. We do this for all the tokens in the text. So if we print the content of the tag tokens, maybe let's print only the first 100, otherwise we get too long. Then we get a list of, we get the same text with named entity information assigned to each token by our baseline, which is very dumb, but you see, for example, Gallia has been tagged as an entity, Bag as an entity, Keltai as an entity, and so on. And this is represented as a list of tuples. Here we printed the first 100. You can also print the first 50, so you can change the notation, the slice notation, to get a different amount of text. You can also wrap your code, as Francesco has showed already, into a function. And this makes it nicer, but also more easily documentable, more modular, and easier to call. So in this case, we can wrap our baseline into a function called extract baseline, which takes one parameter. And this parameter is the input text already tokenized. So it's not a string, but it's a list. No, it's a string. We tokenize it later. So it takes just a string, which is the input text, and then essentially I wrap the code that I showed already into a function. The result of the function of the processing is stored into the tag tokens variable, and this variable is returned by the function. So the input output is, as an input, a string representing the text, and as an output, I get a list of tokens where each token is a tuple. And this makes it easier to call our code. So we can call it like this. We can initialize a new variable called tag tokens baseline, where we put the result of this function, and then we call extract baseline with parameter the variable that we initialized before. And this is the same output that we had before. This was the first method that I wanted to show. Well, you can also do some a bit fancy things, like, for example, showing the context where the entity is found. So we can modify the same function, essentially just adding a print statement. And the print statement will show the entity, we show the token only when this token is recognized as an entity. And then we'll print the token together with its context, 5 words before and 5 words afterwards. So if we run this modified version of the function, what you get is, for each entity, the print found entity Gallia, found entity Beggar, and then the context where the entity appears. And this all the way down for all the entities that were found. If we want to know, all the entities that were found. You can also do it with other libraries, for example, with CLTK. CLTK, it's a toolkit to work with languages, with the historical languages. So there is support for Latin and Greek, and they also have some basic support for named entity extraction. The way that the CLTK tagger works is different from the baseline. Essentially, it works by the list lookup. So for each token in a text, checks if that token is contained in a list of proper names. So for Latin, there is a list of Latin proper names, which is also available on GitHub, on the GitHub repository of CLTK. And for Greek, there is a Greek proper names list. So it's also not a very sophisticated method, but it's already a step forward compared to our done baseline. So this will take a moment, so approximately 15 seconds, so I can run it again. I can run it already. And we run it with this special command here, which belongs to Jupyter, and essentially says, keep a timer and let me know how long it takes to compute this function. Let's have a look at the function. So the function comes from the library CLTK. And one thing that I can do, for example, is to display some documentation for the function that comes directly from the code. But I can close this now. So what we, well, the parameter that this function takes are three, essentially: the language, the input text, and the output type, which by default is a list. Once we run this, then we store the resulting output into the variable text CLTK. Let's have a look at what's inside so that we see the format that was outputted by CLTK. And then we see a list of tuples, but compared to the tuples we had before, the size of the tuples varies. It's not always one, it's not always two, but it can be either one or two. So when the token is not an entity, then there is just a token. When the token is being recognized as an entity, then there is the label entity. Since we want also to be able to compare the two outputs of the baseline and of the CLTK, we should make it consistent. So we can write a function that I called reshape CLTK output, where the input is the list of tokens returned by CLTK, and the output it's another list of tokens, another list of tuples, but having the same size. And it's another for loop. So as you can see, for loops are used really heavily, with another if statement. So for loops and if statements are two essential parts of this programming language. So for each token in the output of CLTK, we check the size of the tuple. If the size is 1, then we add the other label to the tuple. If the size is 2, then we copy its content. And by doing this, here we call our function with the output of CLTK. Then we get a text, we get a list that has the same structure of the list outputted by the baseline. And one thing that you can do is, for example, to show them side by side, and by doing this, also get a sense of the difference between the output of the baseline and the output of CLTK. So tokens that are recognized by one method, but not by the other, for example. So here you see an exception in action. I think I'm referring to a variable that does not exist yet. Let me remove it. Okay, now it's not complaining anymore. I will not go into the detail of the zip function. It's a built-in Python function that essentially takes two lists and goes in parallel, two or more lists, and goes in parallel through each of the lists and shows the same element for each of the lists. So in this case, for example, you can iterate through the output of the baseline and simultaneously through the output of CLTK and show them side by side. So you can see, for example, here, so in the first column, you have the output of the baseline, and in the second column, you have the output of CLTK. So in this case, they both recognize as an entity. In this case, the baseline method did, whereas no, here there is another problem. As you can see, the two lists are not synchronized. So at this point, at the level of TRES, the two lists go out of sync. So what is happening here is that the tokenization method used by the baseline and used by CLTK are different. CLTK is treating the comma as a token, whereas in my baseline, I treat the comma as part of TRES, which is not optimal. But that was the method we used for the tokenization. So let's try to fix this. And we can fix this because the method tag NER from my CLTK can take two types of input. So you can pass it a string as an input. Let's bring up our documentation. Maybe it's written there. You can either pass it, well, it's not in here, but it's in the code. You can either pass as a parameter a string, but you can also pass a list. So in this case, we can pass the same list of tokens that we also gave to the baseline. And this should fix our problems, or our problem of the two lists being out of sync. So this will also take some other seconds. But at least now the two, you will see the two lists they use the same tokenization. So there will be a correspondence between the tokens in the two lists. Here we print it, and here you can see we solve this problem. So TRES has the same tokenization in both lists, and now you can compare them. So you can see Belgrade here has been recognized as an entity by the baseline, but not by CLTK. These were the first two methods. I think there is enough time to show briefly to add another method. In this case, it's not rule-based like CLTK. It's based on machine learning, and I will not go into the details of which statistical model has been used by the Stanford tagger. I will just say that the Stanford tagger was developed by Stanford, and it's accessible via the library NLTK. And there are models for several languages trained to recognize entities from text written in different languages. So there is a model for Italian, a model for English, for German, for a set of languages. It's a trained model, meaning that the algorithm, the statistical model behind, is trained based on some examples, so the so-called training data. These examples are showed to the algorithm, and the algorithm learns what constitutes a named entity and what does not. This a bit to simplify things that are actually a bit more complicated than that. But if we run the Stanford tagger taking the model for Italian, this is a variable where we pass the location in our file system on our machine of where to find this model. Then we pass this variable as the parameter of the object Stanford NER tagger. And what we get back, it's one instance of the tagger. We get a confirmation of that. Then we call this object using the tag method, which is similar also to the CLTK tag NER method, which takes a text and tags it by assigning named entity information. So we do the same that we did in the other two cases. We call this method, passing the tokenized text based on the white space, and then we get back a list of a tagged text. We save it into a different variable. Here we can examine what we got back as output. Let's print the first 50 tokens. What you can see here already, a difference from the other two methods. Here it's using more granular labels for the named entities. For the locations, it's using loc. For the persons, it's using pair. and org for the organization. So this is already a difference between the other two methods that we use. We can now use, once again, the zip function that we used before to display the output of these three methods, the first 50, let's do the first 50 tokens, side by side. So baseline, first column, CLTK, second column, and NLTK on the third column. And you can see it here. So you can start comparing how different methods of accepting named entities have tagged the same text. This is maybe it's not particularly readable as an output. We can also write a for loop printing the information in a nicer way. So for each, we iterate token by token for each output that we received, and then we print it on the output. And what you see here, these characters, this %s, they are placeholders for the value of a variable. So in this case, we define 3 placeholders for strings, and these strings come from these variables. And these variables, in turn, are initialized as we go through this for loop. So as you can see, once you start combining the different pieces of the programming language, things can get more complicated. That's it for today. In the next section, we are going to review some of the things that we have seen today, but we will also go into the issue of how can you actually evaluate how accurate are different methods. So we will start from this example of these 3 baseline CLTK and NLTK outputs, and we will see which measures, which methods exist to be able to assess the accuracy of their outputs. Nope.
Great, thanks very much, Matteo and Francesco. Do you want to very quickly, I mean, we've gone on a little bit longer than usual, but I think that's okay. Do you want to very quickly talk about the exercise?
Yes.
That we want people to do?
Yes, that's a good point. Let me share again the exercise. It's actually quite simple, and we ask you to work on a different text. So instead of working on the Latin edition of the Bello Gallico, we'll be working on the English translation. And this means that we also want to use the right model from the Stanford Tagger. We already gave a hint, so we provided the address of the model in the machine. And what you asked to do is to, once you made a copy of this notebook, you can rerun the various parts and also change the 2 bits that do the extraction with an LTK, and also the part that gets the text via the CTS protocol from Perseus, using the URN for the English text. And in this way, you won't be working on the Latin. So once you pass this URN to the resolver from the MyCapitaine, then what you get back is an English text, not a Latin text. And then you will have, of course, a different output.
Great. Okay. Does anyone have any questions or comments that they want to make? Anyone who's on the call? Everyone's happy? Everyone's sure they know everything they need to know about using Python for a named entity extraction? Okay, yep. I don't see any questions on the YouTube live chat either. The only question I do see is on not a question. Someone has commented on Twitter. Thibaut Clarice has said that this is the first use he knows of My Capitaine being used in a non-web way outside of Persians and Open Greek and Latin. So thanks, Matteo.
And it works.
Good.
Thank you, Gabby.
Well, maybe we can say to Thibault that probably one thing that you should add in the documentation is to say that if to run the example code, one should install the latest version from GitHub. But that's an internal message to him. So that's
right.
Yes, that's also a recommendation to all the people that will want to run our code not in their local machine. If you have trouble installing some of the modules, then go back to us and ask questions, and we will.
And I think we will put on the GitHub wiki some more detailed information, some links to instructions. There are lots of instructions on the web about how to install Python on your local machine, depending if it's Linux, Mac, or Windows, and we'll put the links on the wiki.
Great.
Indeed.
Cool. Great. Well, thanks very much. We'll see how everyone gets on with that. My students will be trying it out over the weekend, and we'll have a session about it next week. I'm sure other people will as well. And we look forward to your second session in 3 weeks' time, I think it is, or 4 weeks' time on April 20th.
Yes.
So we'll look forward to that. Okay, so thank you very much, and we'll see you all again next week, where Eleni Bodzia from the University of Florida is talking about developing linguistic metrics for the analysis of ancient Greek. So see you all then.
Good.
Bye.
Cheers.
Thank you.